Example 8.4.3. And with this one, we're going to use the CAPM, the capital asset pricing model, to find intrinsic value and then compare that to current price to make a buy to sell decision on a stock. And what we're going to have with this one is the exact same setup as we had in example 8.4.2, where in the previous example, we used the CAPM to calculate the minimum required return, and then we calculated the expected return on the stock and compared those two to see if the stock offered a high enough return to compensate us for its risk. And we're trying to make a buy-sell decision based on that. Well, I mentioned in that video that there are two different ways you could use the information in the problem to make that kind of decision. One is to use the returns, like we did in example 8.4.2, the one right before this. We could also do the same analysis based on prices instead of returns. So that's what we're going to do here. There's no reason in the real world you would use both of these methods on one stock. You would pick the one that makes more sense to you, whether you want to calculate intrinsic value and look at prices, or calculate expected return and compare that with the required return. Both of those methods will yield the exact same conclusion. This is just a kind of a neat way to see the relationship between returns and prices and understand that it's one coin and you're kind of just flipping it over. When you're looking at price, you're looking at one side. You flip it over, you're looking at returns, you're looking at the other. But the two are directly related and provide the same information, just in a little bit different format. Okay, so the setup for this one. Suppose you are considering buying a stock. The stock is currently trading for $50. You expect the price in 1 year to be $51, and it will pay a dividend of $5. You estimate the stock's beta at 1.4, the risk-free rate at 2%, and the expected return on the market at 9%. This should actually be 9% here. The 10% is a mistake that's currently in the text. According to the CAPM, should you consider purchasing this stock? Okay, we're going to start with the CAPM because whether we're looking at returns or prices, we need that piece first. So we just plug in the information from the problem to the capital asset pricing model to get the minimum required returns. That R sub I is a required return on just some asset I, is equal to the risk-free rate as our base to compensate us just for the time value money, and then plus a risk factor for this particular asset, where that risk factor is defined as beta for asset I times the quantity of the expected return on the market minus the risk-free rate. All right, so we'll just plug all this information in. The risk-free rate from the problem is 2%, so 0.02 is a decimal. Beta is 1.4, so that guy's just 1.4. And the expected return on the market should be 9%. Remember that 10% is a typo in the problem that's hopefully getting corrected soon. So expected return on the market is 9%, and then we subtract out, again, the risk-free rate of 2%. And here we want to be careful with order of operations. We want to do the subtraction inside the parentheses first before we do any multiplying with the beta. So we do 0.09 minus 0.02, we'll get 0.07, and 1.4. Then we can go ahead and do this multiplication. 1.4 times 0.07 will give us 0.98. And then we add that to the risk-free rate of 0.02, and we get a minimum required return of 11.8%. So this is what we need the stock to return in order to compensate us for the risk associated with the stock. This isn't what we think is going to happen. It's what we need to happen in order to be compensated for the risk. Okay, now what we're going to do is we're going to take a little bit different look at the actual stock itself. And we're going to do, just like we did in the very first examples in this chapter, we're going to use that minimum required return from the CAPM to calculate an intrinsic value for the stock. That is what we think it's actually worth given its risk. And then we'll compare that with the current price to see if it's going to give us more or less return than we actually need. So in order to calculate the intrinsic value, we've got a time value money problem. So we're going to follow our three-step process here. I just noticed there's now a formatting issue with this timeline. I guess the publisher must be playing with this while we're in the middle of this. But the present value is what we're looking for now. So we're going to calculate the intrinsic value of the stock, and we want to map out the expected future cash flows. This one should be right here. We expect the stock to be trading for $51 1 year from today and receive a $5 dividend 1 year from today. All right, and what we want to do is discount these expected future cash flows at the minimum required return to come up with that intrinsic value. We'll treat this guy like a lump sum cash flow, so we can use the present value of a lump sum calculator or the time value money keys on a financial calculator or a spreadsheet if you have access to that. If we're using the formulas, you've got this guy here. If you're using the financial calculator, which I imagine most of you are. These are the settings you can put in. Now, it's worth noting that I just put that 56. This is 51 plus 5 equals 56, right? I combined the two cash flows that happen at the end of the timeline. Now, I combine those together and put them on the future value key just because that's what I did in the formula, and I wanted those to be consistent if students were looking at both, trying to get a feel for what's going on. Since this is just a one-period problem, it doesn't really matter how you split those cash flows up between the payment key and the future value key. No matter what, no matter if it's on the payment key or it's on the future value key, since it's only one period, the calculator is going to see that as just one cash flow, one period from today. So you can kind of split this up however you want. All right, but if you plug those guys in, which we'll do real quick just so we can be sure we've seen it, I'll put these settings in the calculator and get that present value. So our N is 1. Type in 1 and then N. Our discount rate is 11.8%, so type in 11.8 and press I over Y to store it. Present value is what I'm looking for, so I'm going to skip over that. Payment doesn't have anything here, and the way I've written it, it's going to be a 0. Again, you could put the 5 here, and you could put the 51 on the future value key. Just whatever makes the most sense to you. Because it's a one-period problem, it really doesn't matter in this case. But I'll leave payment blank. And I'll record the future value as a positive 56 because I'm looking at it from the perspective of an investor who might buy the stock. So that's going to be a cash inflow for me when I receive the dividend and sell the stock. And then we can compute future value. So hit compute present value. Okay? And there's our $50 and roughly 9 cents that we were getting. That's got a negative sign in front of it. That's that just keeping track of the relative direction of the cash flows. Saying that if I'm going to receive a cash inflow, or the calculator is saying that if I'm going to receive a cash inflow of $56 1 year from today, and I want an 11.8% rate of return, then I should experience a cash outflow of $50.09, roughly at time period 0. Okay, what do we do now? So we just found the present value of the expected future cash flows using the minimum required return, using that rate of return from the capital asset pricing model. So what we just calculated here, this $50.09, is the intrinsic value of the stock. All right, so that's how much we think it's actually worth. What we want to do now is take this intrinsic value and compare it to the actual price of the stock and see if it offers us enough value to be able to buy it. Well, the stock is currently trading for $50, the problem said, which is less than our intrinsic value. We think it's actually worth $50.09. Well, it's trading for $50, which means if we bought it at 50 and then received the expected future cash flows, our rate of return would actually be higher than 11.8%, and the stock is more than compensating us for the risk we think is embedded in the stock, the risk it would contribute to a well-diversified portfolio. So we come to a buy decision here. This one looks attractive, and we would consider buying it. And now note, that's exactly the same conclusion we came to in the previous example in 8.4.2. Here we use that same capital asset pricing model, but we calculated the expected return based on a price of $50, right, and came up with an expected return of 12%, which is higher than our minimum required return, so we said we would consider buying it. In this example, we did the same type of analysis. We just did it using prices instead of returns. And again, there's no reason you would do both. This is just a neat way to kind of see the relationship at work here. And in reality, you can pick whichever one of these methods makes the most sense to you. If you find one really confusing, but the other one kind of appeals to your intuition, we'll run with that one. That's perfectly fine. It's not like one provides more information than the other one does. It's really the same information, just packaged in a different way.